European citizens and governments rely on satellites for a growing number of crucial tasks. Any shutdown of these systems would seriously affect an enormous range of commercial and civil activities, including travel, transportation, telecommunications, information technology and broadcasting, to name but a few. Yet space is a hazardous environment. The sun lashes out unpredictably, emitting particles and radiation. This harmful space weather can blind a satellite or degrade networks on Earth. Space debris is a growing hazard. Today, more than 700,000 man-made objects larger than 1 centimeter, big enough to seriously damage or destroy a satellite at orbital velocities, are clouding the Earth environment. Our planet is also threatened by near-Earth objects, comprising natural asteroids and comets that could strike Earth. But today, Europe has no autonomous capability to watch for and warn of hazards to its vital satellites and ground infrastructure. In 2009, ESA member states asked the agency to embark on a new program, known as Space Situational Awareness, or SSA. Now in its initial phase, SSA aims to develop Europe's own scanning, detection and warning capabilities against space weather, space debris and natural near-Earth objects.
Today in Europe we are lacking a good network of sensors. Radars, telescopes are components of the SSA system which are really missing today.
Space debris is perhaps the most urgent cause for concern. In 2010, ESA's ENVISAT, ERS-2 and Cryosat missions were alerted 49 times to possible collisions, twice the count of the previous year. Most proved to be near misses, but in 9 cases, these valuable satellites had to conduct avoidance maneuvers. ESA's multi-year SSA activities are accelerating in 2011, with the opening of a space surveillance data analysis capability at ESA's European Space Astronomy Center near Madrid. It will serve as the testbed for enhanced debris analysis and for issuing test warnings to satellite operators.
What we aim to do in the European SSA program is to provide a global database of objects which are orbiting the Earth, and to be able to provide full and complete information to satellite operators so they can take the most efficient avoidance maneuvers to ensure there isn't a collision with anything else in orbit.
We are planning to develop new systems. Especially we are aiming at establishing the next generation space weather sensor system, both in space and on the ground. So it's an enhancement over the existing capability.
In 2012, the initial phase of the SSA program will reach fruition, producing a detailed technical roadmap for the future fully operational SSA system.
There is a strong will and I would confirm agreement in Europe for the development and availability in Europe of a certain degree of autonomy in this domain. It is different from independence. We are not seeking full independence, but autonomy is a clear objective.
The plan will show how existing European research capabilities can be efficiently integrated into the system and specify the new sensors, telescope, scanning radar and data processing capabilities that must be built in order to secure Europe's autonomy.
We are really addressing here phenomena, objects which are of international nature, and when you have space debris hitting a satellite, generating additional space debris, it's an event which in fact affects all the spacecraft operators.
Until then, the agency's SSA preparatory activities will continue in the sure knowledge that to be forewarned is to be forearmed.